Welcome. Let's discuss the idea of domain and range of a graph. Let's start by considering the function of f of x equals x squared, and let's try to think about how we can define the domain and range of this function. The graph of the function of x squared, it is shown right here on the left-hand side. With just a small review, when we use the word domain, we will be looking at all the possible x values that the graph can have. And when we're using the word range, we are going to be looking at all the possible y values that the graph can have. Let's start by concentrating on the domain of this function. If we're going to be looking at the x values of this graph, then we are going to be concentrating on the x-axis of this graph. Well, notice that the x-axis runs infinitely to the left and also infinitely to the right. Let's analyze one direction at a time. So starting from 0, let's look at all the possible x values on the left-hand side of 0. Let's look at all the possible values infinitely going to the left. Well, the first thing to point out is that notice that on the left-hand side, we do have an arrow at the end of the graph. That is saying that we are going to be moving infinitely to the left. There is no bound on the left-hand side. And notice that with the graph that we are given, if we look at the x values, if we keep moving towards the left-hand side, notice that I'm always going to be able to find some y value that goes with it. If I keep choosing more x values to the left, I am going to be getting another value on the y. And one thing to recognize is that this function does not have any holes in the graph. And this function does not have any kind of asymptotes on the left. And when we combine all these ideas together of having no bound and using every single x value, because we can always find some y value on the graph, then we can say that we are allowed to use every x value on the left-hand side of 0. One way to represent that idea is to say that we are going towards negative infinity. Let's look at the direction on the right. Notice that as I keep moving to the right-hand side, I'm going to always be able to identify a y value that goes with it. If I choose another x value, I'm always going to be able to get a y value for that. In addition, also notice that we have an arrow pointing up. So there is no bound. There is no hole in the graph. There is no asymptotes on the graph. So we can say that we are allowed to use every single x value on the right-hand side of 0. We're going to call that positive infinity. So now let's try to represent this idea using interval notation. An interval notation, it is a description of what are the values that we are allowed to use. So for domain, let's look at all the possible x values that we are allowed to use. When we go infinitely to the left, the lowest x value that we can have is negative infinity. And when we are going infinitely to the right, the highest x value that we can get is positive infinity. So this describes the possible x value that we can have. But now we gotta introduce some notation. If we would like to include a value in our interval notation, then we will use a square bracket. And if we would like to not include the value in our notation, we're going to use a curved bracket. Now, as we're going infinitely to the left, does it make sense for us to include the value of negative infinity? It doesn't. Infinity is not a value. It is just an idea. So on the left-hand side, we do not want to include the value. Therefore, we need to use a curved bracket. And the same goes on the right-hand side. On the right-hand side of positive infinity, does it make sense for us to include the value of positive infinity? It doesn't. Infinity is not a value, it is just an idea. So we cannot include it. We're going to use an open parenthesis. So now we have defined the domain of this graph. Now let's take a look at the range of this graph. And let's remember that for range, we'll be looking at all the possible y values. Well, let's start by looking at the y-axis. But notice that we don't have to take a look at the whole y-axis as we did when we were looking at the domain. Because notice that the lowest y value in this graph, it is occurring at y equal 0. So it is sufficient to just take a look at the y values that are higher than 0. So now we know the lowest bound when it comes to y value. It is equivalent to 0. Now let's think about the highest y value that we can obtain. Well, recall that we do have some arrows pointing upwards. So we are claiming that our function increases up without a bound. So we can say that if we are increasing without a bound, we are approaching positive infinite values. And when we mix these two ideas together, now we can define the range of this function. The lowest possible value in terms of y, it is 0. And the highest possible value, it is positive infinity. Now let's think about what parentheses should we use. Notice that this function, it is using the value of 0. We want to include the value on 0 in our notation. So to include it, we will use square brackets. And when it comes to infinity, we cannot include infinity. Infinity is not a number, it is an idea. So we will use a curved parenthesis. Let's take a look at one more example. So let's consider the graph on the left. Let's start by identifying the domain of this function. Let's look at all the possible x values that we can use. One thing to notice is that now in this graph, we do not have arrows pointing up or down. So we know that this function will not move without a bound. And if that is the case, notice that the lowest x value that this function has, it is equivalent to -2, and the highest x value that this graph is displaying, it is a +2. Therefore, we can claim that the x values will only take place between -2 and +2. Therefore, this is the domain of this function. The lowest x value is -2, so it goes on the left. The highest x value, it is +2, it goes on the right. And notice that at -2, we do have a circle that is filled in. This is implying that we need to include this value in our domain. So we will use a square bracket on the left. And the same goes on the right-hand side. Notice that we have a closed circle, so we need to include this value as well. So we will do a square bracket as well. Now let's take a look at the range. For range, let's look at all the possible y values that this function has. So let's start by looking at the y-axis of this function. But notice that starting from 0, the highest y value that this function gets, it's a +8. And starting from 0, notice that the lowest y value that this function gets, it's -8. Therefore, our range are between the values of -8 and +8. So the left bound is -8. The right bound, it is +8. And one more time, notice that we have a closed circle. We want to include the value of -8. We have to do a square bracket. And on the right-hand side, we have a closed circle at +8. We want to include that value, so we'll do a square bracket at +8 as well. Let's take a look at our last example. Given the graph on the left, let's take a look at the domain of the function. Let's take a look at all the possible x values. So this graph, it's a little bit different than the ones that we have seen, because we do have two types of asymptotes. We have a vertical asymptote at the value of x equals -2, which is displayed as this vertical dotted line in our graph. And we also have a horizontal asymptote at y equals 4, which is displayed as this horizontal dotted line in our graph. So if we look at all the possible x values, we're looking at the x-axis, but notice that this x-axis, it's getting cut by this vertical asymptote. So we are going to split the x-axis in two sections. The section that is on the right-hand side of this vertical asymptote, and the section that is on the right-hand side of this vertical asymptote. Let's start by looking at the section on the left-hand side of this vertical asymptote. Notice that in this section, when it comes to the function, which is displayed in green, there is no holes in the graph, and we are moving infinitely upward. So we can say that the x values that are being used in this section are all those x values that are on the left-hand side of -2. So the left bound is -infinity. The right bound, it is -2. We do not want to include -infinity because it is not a number, but also we do not want to include the value of -2 because that is the vertical asymptote. So we will do a curved bracket as well. Now let's take a look at the right-hand side of this vertical asymptote. Within the right-hand side, notice that our function, there is no holes on it, so we can claim that we can use all the x values on the right-hand side of -2. So within the section on the right, the left bound is -2 and the right bound is positive infinity. We do not want to include -2 because that is the vertical asymptote, so that's a curved bracket. We do not want to include infinity, but that's not a value, it's an idea. So that's a curved bracket as well. So we have defined all the possible x values that this graph can take. But we do not want to just display it as we have done right here. We're saying left is this, right is that. We need to combine these two ideas. And for that, we will use the notation of union, which is just a U. A union is when we combine two different intervals in one statement. On the left-hand side of the union, we will write down the interval that is to the most left-hand side. And on the right-hand side, we will use the interval that is the most right-hand side. So on the left-hand side, we have the interval -infinity to -2. So that is the interval that we will write on the left-hand side of the U. And on the right-hand side of the union interval, we're going to write down the interval for the right-hand side of the graph, which is -2 to positive infinity. So we are done. We have defined the domain of this function. Now let's concentrate on the range of this function. So let's concentrate on the y-axis. So notice that the y-axis is also getting split into two sections by this horizontal asymptote. The section that is up and the section that is down. Let's look at each section individually. Let's start by looking at the section that is above the horizontal axis. Notice that in that section, we are just going to consider the left-hand side of the graph. Notice that there is no holes in the graph. So within this section, notice that the lowest y value, it is of 4, and the highest y value, it is of positive infinity. So within this region, we can represent it as the left-hand side behavior as +4 and the right-hand side behavior as infinity. But notice that we are not including the value of +4 because it is an asymptote. And if we take a look at the bottom side of this section, we are looking at the left-hand side of the graph. There is no holes in this graph, so we are allowed to use every single y value in this section. And the lowest y value in this section, it is from -infinity, and the highest y value in this section is +4. Well, we will not include -infinity, because that's not a number, and we will not include the value of 4, because it is an asymptote. So now let's represent this idea in one notation. Let's use the union notation. On the left-hand side of the union notation, we have to express the interval that is the lowest, which is from -infinity to +4. And on the right-hand side of this union notation, we will use the interval that we have defined as the upper interval, which is from 4 to +infinity. So we are done. We have defined the range of this function. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.